Hello, dear students. Welcome back to my YouTube channel. Am I audible? Let me know if I am audible and visible to all of you. Hello, 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 hello. Hello, beta. Am I audible and visible? One second. Mm-hmm. Okay. One second. Thank you, beta. Thank you, thank you, thank you, thank you. Okay. One second. Okay. So I guess you already knew that we are going to start a new chapter. If you can find it in your NCRT part first of 12th, that is magnetic effect of current. It is chapter number 4. First one is electric charges and field. Second one is electric potential and capacitor. Third one is current electricity, and fourth one is magnetism. Okay. So today we will be starting magnetic effect of current, lecture number first. I guess you all are very ready for it, no? Yes. You all be ready for it, no? Beta? That is great. Okay. So we have magnetic effect of current. Shall we start now? Shall we start now? Yeah, definitely we need to start it. Okay. So I guess the screen is very visible to you. Okay. If you have any confusion or if I'm not visible and my screen is not visible to you, you can just let me know now. Okay. And who is present now? Let me just check it. Who is present? One second. So as I can see here, good vibes, Sasana, yeah, and more students are present in session. Okay, beta. Now let's, as we are just completing one chapter and one more chapter and one more chapter now, you will find the importance of the previous one now. Why? Because look, maximum things are not getting repeated. If you can just analyze the whole scenario, now maximum things will be repeated. Formula part, derivational part. Okay. So you will find the effect of electrostatic current, magnetism, sorry, if current and capacitor in this particular chapter. If you have not taken those chapters seriously, definitely you will find some sort of uh, confusion and some sort of issue with this particular chapter. And it is my sort of, uh, I will not take your more much time. So let's start. So hello, 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 hello. Yes, I guess I am audible now, right? Yeah, some after some certain period of time, na, my internet it feels inferior, right? That's why it just give me this sort of black. One sort, one thing, one thing. I guess I am now audible and visible to all of you, no? I guess I am now audible and visible to all of you now. Okay, you can just let me know in the comment box. Am I? Hmm? Okay, I am audible. Okay. Sometimes no, it happens no. I guess you are all very used to my network sometimes no. Okay, let's start now. Okay, I am audible. Okay. So, sir, how is Executor Abhishek Sahu, sir? But I don't know really. I have not done this book, so I don't have any idea about it. Okay. So we will be starting magnetic effect of current. Magnetic effect of current. So what is the meaning of magnetic effect of current? In the whole chapter, we will study that whenever current flows through any conductor, around the conductor, there will be a magnetic field. There will be a magnetic field. So first scientist which observed this particular phenomena or application of flowing current known as Oersted. So you have studied about the Oersted experiment, right? Oersted experiment. Oersted experiment. That is, if we have a wire, if we have a wire and current is flowing through the wire, current is flowing through the wire. Okay, it is the experimental part. Here we have placed a what? A compass. Here what we have a compass. I guess this is a needle of compass and the working of compass is needle gets deflected in the presence of magnetic field. In the presence of magnetic field. So Oersted observed that whenever current flows this through this particular wire or this wire, here what we observe deflection. Observe deflection. So due to this deflection, Oersted confirmed that whenever current flows in any circuit or any wire, around the wire there is a what? Magnetic field. There is a magnetic field. Done? So you can write here current carrying wire produces magnetic field only. Magnetic field only. So now there will be a one question in your mind, sir, why magnetic field? Why not? Why not electric field? Why not electric field? From the electrostatic chapter, we must know that for electric field, one condition is must, that means charge. There should be a charge. If presence of charge is there, so electric field will be there. Now we know that conductor, okay, the conductor is neutral. Before current and the after current, conductor is always neutral. It is always neutral. Why? Number of proton, number of electron equal. It is always neutral. If the conductor is always neutral, that simply indicates that it doesn't possess any kind of extra charge. It doesn't have any extra charge. If no extra charge, that means no electric field. Easy explanation, no? Easy explanation? Yes. So current is a neutral body. Even though current is passing through it, okay, still number of proton, number of electron equal. No charging of that particular thing takes place. So you will call it as a neutral body. If this is a neutral body, so no electric effect, only magnetic effect. And this experiment is known as Oersted experiment. Done? Now, from Oersted experiment, we conclude what a magnetic field. Magnetic field. The definitional part is very boring, no? Magnetic field. So now if you want to write the definition of magnetic field, similar to electric field, it is the region around the magnetic or current carrying wire. Okay, so I can write here a space around a magnet or current carrying conductor which moving around a magnet or current carrying wire which charge or another magnet or another conductor can experience a force. So now what is magnetic field? It is a region around a magnet or current carrying conductor where a moving charge or another magnet or another current carrying conductor can experience a force. This particular region is known as what? Magnetic region or magnetic field or what? Magnetic field. So we can denote the magnetic field by letter B, vector. Why is it vector? Magnetic field is a vector quantity. Magnetic field is a vector quantity. Then, and to measure it, we have SI unit. So we have Tesla or we have Weber per meter square. If we have different in CGS system, we have Gauss. And you can write 1 Tesla equal to 10 to the power 4 Gauss. Conversional thing. Okay. Okay, we now know now if here we have a conductor. This is my conductor. Okay, here with current I. Now, point number 1, point number 2, point number 3. We know that this conductor will apply a magnetic field here due to the conductor B1 will be here, B2 here, and B3 will be here. Magnetic field. There will be a magnetic field at 1, B1, at 2, B2, at 3, B3. Now, sir, where the magnitude will be more at B1, B2, B3, that means to calculate magnitude of magnetic field, we have two principles, two law. One is Biot-Savart law, one is Ampere's law or Ampere's circular law. So what these laws are? So to calculate the magnitude of magnetic field, we have two laws, Biot-Savart law and Ampere-Savart law. In our electrostatic, we were having first law, that is Coulomb's law and Gauss's law to give us the magnitude of electric field. In the same way here what we have Biot-Savart law and Ampere's law. Done? Okay, now let's start first part of our chapter, very important one, known as Biot-Savart law. Biot-Savart or Savart's law. Okay. If we have a conductor, current I is flowing here. What will be the magnetic field here? So to get the magnetic field, what we need to do? We have to just take the distance between them now. If it is R. So magnetic field due to this small region. Okay. If the length is dl, current flowing is I. Okay, so I can write here ideal. I current flowing through DL element. This particular thing is known as current element. Current element. This is my angle theta. Here, due to this small element, my magnetic field will be small. Okay, done. So according to the law, this small magnetic field is proportional to ideal current element, proportional to the angle theta, that means sine theta, and it is inversely proportional to the distance between them. Now combine all these, so I can write dB proportional to the ideal sine theta by r square. So we have proportionality sign here. I will change it, so I can write dB equals to nu naught divided by 4 pi ideal sine theta by r square. So this line or this box thing is, it is Ampere's circular law. So you can use it for the magnitude purpose. Sometimes we need to write it in a vector form. So I can write dB vector equals to nu naught 4 pi ideal sine theta r square. Now multiply it with r, divide it with r. So I guess I will write it like dB equals to nu naught by 4 pi I dl cross r divided by r cube. So this particular thing is what? Vector form. This one is a vector form. And this was asked in your NEET. What is the vector form of Biot-Savart law? Simple statement was asked in your NEET examination. Done? Okay. So now, what is ideal? It is current element. Theta, angle between element length and distance between wire and point. Done? What is R? Distance between wire and point. Then we have nu naught. It is known as permeability. What is known as? Absolute permeability. That means how much magnetic field can get crossed in any material or any medium, and its value is given to us. It is how much? 4 pi 10 to the power minus 7. Value of your nu naught. I guess it is very easy, no? This chapter is very easy. Okay. Now this was all about Biot-Savart law. Now let us start the application part of it. Okay, application part. Now first application part of it. Application part. First application part. Magnetic field due to straight current carrying conductor. So if we have a straight current carrying conductor, current I is flowing through it, and I will take a distance here. Distance is d. At this particular point, I need to calculate my magnetic field. Done. How to get it? As we know from electrostatic, I need to join the extreme ends. Now I joined these extreme ends. So this is my angle theta 1, angle theta 2. So what I can do here now, I will go y distance upon, I will cut an element of length dl or small dy, no issue. This length is dl or dy. I cutted this element. Or one more thing, I will go theta, cut element of d theta. Done. So I will zoom this one now. So look now, it looks like this, dy. And this one now. If this is dy, let's suppose this one is r. Okay. So if this angle is 90, this angle is theta. This would be 90 minus theta. Look, the whole angle, the whole angle will be 180. So it is 180 minus 90 minus theta. It becomes 90 plus theta. So only this angle. Now upper one is how much? It is 90 plus theta. This one is 90 plus theta. Done. So if you want to write the Biot-Savart law, so what is Biot-Savart law? So dB, it is nu naught divided by 4 pi I. dl or dy, no issue. Then sine theta, or we have r also now. It is I dy r sine theta whole divided by this length r square. Done. R cube, sorry. 1r cancel out, so I can write nu naught by 4 pi I dy sine theta by r square. Look now, nu naught I as it is, 4 pi as it is, I as it is. Now what is dy? What is dy? Okay, here, can I write tan theta? P by B. What is P? Perpendicular is y. Base is d. So what will be y? Y will be d tan theta. So I will differentiate it, dy by d theta. Y, d is constant, so I will do differentiation of tan theta. So I will write here d. So what we have here now? Sec square theta. Okay, dy. I can here like d theta also, no? There is no issue. So now dy is d sec, it is d sec square theta d theta. Then we have sine theta. Whole, what is r? Look, this r, I can write this r as d sec theta also. Okay, I can write here d square sec square theta. Cancel out 1d cancel out. So now dB came out to be nu naught I by 4 pi, it is only 1 I. 4 pi, then what we have here? We have sine theta d theta divided by d. But I don't need this d by d, I need b. So I will integrate it from, it is minus theta 2 to plus theta 1. Okay, minus theta 2 to plus theta 1. So look now, differentiation of d b will be b only. Nu naught is constant, I is constant, 4 pi is constant, d is constant. Integration of only what? Sine theta with respect to d theta. Nu naught I 4 pi d. Integration of sine is cos theta. Done. I think we have done something wrong. Okay, there is one issue with our derivation now. We have forgotten to place one thing here. 1 second, beta. Look, and that is, look, up to this point it is good now. So look now, I will write dB, it is nu naught I 4 pi sine theta is 90 plus theta, then d theta whole divided by d. Sine 90 plus theta is cos theta. I can write dB nu naught I 4 pi d cos theta d theta. Now I need to integrate it. I was thinking, now this is wrong. Okay, now, so I can write b vector nu naught I 4 pi d sine theta theta 1 minus theta 2 nu naught I 4 pi d sine upper limit minus sine minus theta 2, and think that is sine minus theta equals to minus sine theta. Okay, so b came out to be nu naught I 4 pi d sine theta 1 plus sine theta 2. This is my last equation that you need to remember only. This one you need to remember, only this one. Okay, I guess you know the electric field thing also, no? K lambda by r sine theta 1 plus sine theta 2. In the same way here, nu naught I by 2 pi d sine theta 1 plus sine theta 2. There also infinite case, semi-infinite case. Okay, here also. So case number first case. If we have infinite wires, I guess infinite wires means if theta 1 is 90 degree and theta 2 is 90 degree. So what is my value? Sir, B would be equals to nu naught I 4 pi d sine 90 degree plus sine 90 degree. Okay, it is nu naught I 4 pi d sine 90 is 1, sine 90 is 1. I can write nu naught I 4 pi d into 2. So therefore B net came out to be nu naught I by 2 pi d. So this expression is for what? If we have infinite line wire, infinite. If the length of my wire is infinite, for that thing B net is nu naught I 2 pi d. Okay. Now next case. Next case, if you have semi-infinite, B semi-infinite wire. Semi-infinite means simple like this. Look, point P 90. Semi-infinite. Semi-infinite means you can see theta 1 is 90 degree, theta 2 is 0 degree. So what is B net now? So B net came out to be nu naught I 4 pi d sine theta 1 plus sine theta 2. Nu naught I 4 pi d sine 90 plus sine 0. Nu naught I by 4 pi d. Sine 90 is 1, sine 0 is 0. So therefore, B net for semi-infinite wire is nu naught I by 4 pi d. Okay, clear? Clear now? So look, and this thing gets only clear now if basics are clear. Basics means if the Biot-Savart law, that thing is clear. Okay, nu naught I 4 pi d ideal sine theta by r square. Okay, then if the infinite wire is clear, so for infinite wire, if we know, we need to remember this now, nu naught I by 4 pi d sine theta 1 plus sine theta 2. According to the numericals perspective, we have to change it. Now let us suppose we have a wire. I will ask a question now. This is my wire, infinite wire, and my point is here. This is my point. point P. Find current is flowing like in this way. Find magnetic field at point P. How you will find it? Sir, there are two ways. Two ways. One, what is B net nu naught I 4 pi d sin theta 1 plus sin theta 2. Look, nu naught constant, 4 pi constant, I constant. What is d? D is the distance between your point. I guess you can see, na? This particular point lies on all the lines. So my d is 0. One thing. If d is 0, so my b is 0. One way. Second way, this particular point lies on this one. Na? That means theta 1 and theta 2 both equals to 0. If theta 1, theta 2 both equal to 0, so b came out to be 0. You need to think about it. Okay? Clear? Clear? Okay. If this thing is very clear to you, now we got to know that how to get the magnitude. Okay. So I can write here, magnitude part is very clear to us. Magnitude part. Now we need to find direction. We need to find direction. Which one, beta? Kishore Biswal, beta, which one you need to repeat? Huh? कौन सा पार्ट रिपीट करना है आपको वो बताइए आप. Magnitude. Look, for magnitude, na, what we need to find out? Magnitude due to wire. Okay, and it came out to be nu naught I 4 pi d. What happens to it? 4 pi d sine theta 1 plus sine theta 2. This is my formula. Now we have two cases. First case, if we have an infinite wire. Infinite wire. Infinite wire means theta 1 and theta 2 both equals to 90. Now place 90. It is sine 90 plus sine 90. Sine 90 is 1, 1 plus 1 is 2. So you will get the answer nu naught I 2 pi d only. Okay. Second part, if we have semi-infinite. Semi-infinite. Semi-infinite means beta, if theta 1 is how much? 90 and theta 2 is 0. There we will get nu naught I by 4 pi d. Okay, it seems to be difficult, but when we are doing the same thing from the electrostatic, na, there also we had a formula for infinite wire, semi-infinite wire. Okay. Second part is direction. Now, sir, how to find direction? This one is very easy. For directional part, we need to use a right hand. Okay, we use a right hand thumb rule. That means what we need to do here. Firstly, thumb. Place your thumb in the direction of current. Okay. Suppose this is my wire, current is I is going here. Now, place your hand, take your hand and just place it on the wire in such a way that your thumb should be in the direction of current. I guess if this is my hand, okay, this is my hand, so my thumb will be in this way. Okay, Now my fingers will be in this way. Done. Now you need to curl your fingers. We need to curl our fingers. So the curl one gives the direction of magnetic field. That means, or one more thing, that just place your thumb in the direction of current. Place your this one, the nail part. Place your the nail part towards point. Okay. So this is my hand. This is my wire. Look, it is going upwards. Place your hand in this way. Now, if here I want to find out, just open my hand. So this direction, the direction of my palm, is it inside? Yes, sir. So direction of my palm is magnetic field. So here my palm is inside, so direction is inside. Now if I want to find here, take my hand. Okay, this is the wire. Current is going upwards. I need to find here. Take my hand. Place my thumb in the direction of current. Now just place this one in the direction of point. So is it like this now? Okay, you can see the palm is in my direction. That means it is outside. It is outside. It is dot. Cross means inside. Dot means outside. Okay, let us do some practice to it now. Let us look. Let's suppose now second one now. Current is going in this way. I. Point A is here. Point B is here. Find direction of magnetic field. My hand in this way. My fingers will be downwards. So palm is inwards, right? Look, my thumb is in this way. Fingers in this way. Palm inward, that means cross. My fingers in this way. Thumb in this way. Fingers in this way. Palm is outside. It is outside. Done? Look now. If I have like this, current is going downwards. I need to find here at A, at B. Take my hand. Okay, current is downwards. Okay. A is here, palm is inside. So my magnetic field is inside. Downwards, B is here, it is outside. So I will write it dot outside. Done? So by doing this thing, we concluded that, sir, how to find the direction of magnetic field and how to find the magnitude plus direction of magnetic field at any particular point. If you have any confusion, you can let me know. Any confusion now? If you don't have any confusion, then I need to complete couple of numericals then. It is the work of your hand. Place your thumb, direction of current, finger, direction of point, palm, direction of magnetic field. Okay, now if everything is good to you now, so let us do a couple of numericals. Look now, numerical portion. I have an infinite wire. Okay, sir, infinite wire. One more infinite wire. One more infinite wire. And these wires are a distance apart. Okay, so this particular point is point P, which is at middle. That means a by 2. Current I is flowing, or I1. Current I2 is flowing. Okay, so we need to find what will be the B net. Okay, wire 1, wire 2. So magnetic field due to 1 will be nu naught I. It is infinite, that means 2 pi d only. But we don't have d, we have a by 2. I can write nu naught I, 2 pi a by 2. B2 same, it is nu naught, it is I1, nu naught I2 divided by 2 pi a by 2. Now look, as per the directional properties, the current I1 is flowing upwards, so I1 magnetic field will be inwards. I2 is going downwards, so it is magnetic field also inwards. Both inwards, so B net would be B1 plus B2. It is nu naught I, 2 to cancel out, divided by pi A plus nu naught I2 divided by pi A. So I will take nu naught by pi A common. It is I1 plus I2 now. B net. This is how you need to do your numericals. Done. If this thing is done, you know that with the one numerical, we are increasing the toughness of numericals. If this thing is done, then I will do a tougher one. Okay, done now. One more numerical. And numerical is like infinite, infinite. Here is the point P. This distance is given to me A. This one is A by 2. Current I is flowing. Current I is flowing. That means current I will be in this way. Current I will be in this way. Okay. So what we need to find out is that B net here. B net. Look, if we talk about this line, I will just increase it now. So this line magnetic field is 0. This one magnetic field due to 1 is also 0. Now this one is a semi-infinite. Now where they're talking about from this one, it is semi-infinite now. Semi-infinite. This one also, it is semi-infinite. Look, if we talk about direction now, I due to this one, it will be outwards. So I will write it outwards here, dot B1. Due to this one, B2, it is also outwards. So my B net would be B1 plus B2. What is B1? B1, no? B1. So B1 would be nu naught I divided by, it is 4 pi D. What is D? D is A. Okay. B2, it will be nu naught I divided by 4 pi A. A is A by 2. Or for simplicity, I will write 2A. 2A, now let's talk about 2A. 2A. It is 2A. So I can write nu naught I divided by, I will take 2A only now for my calculation part. So I can write B equals to nu naught I 4 pi A plus nu naught I 4 pi then 2A. I will take nu naught I by 4 pi A common. I have 1 plus 1 by 2. So it came out to be nu naught I divided by 4 pi A. It is 3 by 2. This would be my answer. And net resultant would be outwards. Dot. Any confusion? Huh? Any confusion now? Okay. Now, no confusion? Huh? Okay. One more numerical. If we have a square, it's square. Done. And at the here, now here at center, I need to find magnetic field. Length is A. Current I is flowing. I. Look now. I will add like this. Okay. Then I will take inner one. If this is A, so the upper one will be A by 2, lower is A by 2. Done. And look, this will be 45 degree. Why? Because it is a square, na? Okay, sir. So if the whole is A, this one is A by 2. So I would write to find B1. B1, na? B1, it will be inverse. So what is B1? B1 is nu naught I 4 pi D sine theta 1 plus sine theta 2. Nu naught I divided by 4 pi. If this one is A by 2, so similar, this one will be A by 2. You can do the calculation also, no issue. So I can take it 4 pi, it is A by 2, then it is sine 45 plus sine 45. Okay. 2 cancel out, so I can write nu naught I 2 pi 1 by root 2 plus 1 by root 2. It is nu naught I 2 pi 2 by root 2. Done. Cancel out. Nu naught I root 2 pi. This is my answer. But this is only for this one, no? It is only for this one. Similarly, how many sides we have? Sir, we have 4 sides. We have 4 equal sides. So what will be B net? 4 into nu naught I divided by root 2 pi. I cannot write it. It is 2 root 2. It is nu naught I divided by pi. I guess this is my answer. This is my answer. And it will look, this one will be also inverse. This one is inverse. This one is inverse. That's why I just write what 4 times nu naught I for this one now. I will give you one trick also. Trick, no? You don't need to then learn all these formulas. Trick is for regular polygons. For regular polygons. That is B at center. It is valid only for center. It is n nu naught I by pi times A. Then tan pi by n sine pi by n. So what is n? N is number of sides. Number of sides. So here you will see now. Look, what is n here? 4. N here 4. Now I will take n as 4. N as 4. So can I write here? It is 4 nu naught I divided by pi a. Simple. Then it is tan pi by 4 sine pi by 4. So B at center came out to be, it is 4 nu naught I divided by pi a. Tan 45. Tan 45 is 1. Sine 45 is 1 by root 2. So B at center came out to be 2 root 2 nu naught I by pi a. Look, this answer and this answer, both are same now. But the upper one takes so long time, no? Lower takes the minimum one now. So this was a short trick. It was a short trick. Okay. If you have now 5 siders, 6 siders, you can just place the siders, no? 6. Only you need to change the n part now. Any confusion now? Any confusion? No? So what we can do now? I guess I will stop now. If you have any confusion from this particular class, you can ask me. If no, then what I can do? Tomorrow we'll start from this particular thing. Okay? Because in a one day, it is not a good to give that much of quantity, right? I guess up to this one you are very good. So how many things we have done? Firstly, Biot-Savart Law, nu naught I dl sine theta by 4 pi r square. Second formula, due to a straight wire, nu naught I 4 pi d sine theta 1 plus sine theta 2. Then we have an infinite. For infinite, nu naught I 2 pi d. Semi-infinite, nu naught I 4 pi d. So these things we discussed in today's class. So in tomorrow class, we will continue from this particular numericals. That means how to find magnetic field. So for today, I guess we have done. If you want to ask me anything about this particular chapter, you are most welcome. If not, then we can end the session. Okay. And okay. So from next class, make sure that we will continue the session up to 12 o'clock. That means 1 hour, 30-minute session, 90-minute session every day. So I guess we need to stop now. Then thank you, beta. Thank you. Bye.